Good morning, I'm Dr. Janardhana Rao. We are discussing about operating systems since almost 30 classes. Today my topic is goals of protection. Why we should give some protection to the OS and the programs. How the OS will provide the protection to the systems programs. So that we'll discuss. So goals of protection. So obviously to prevent malicious misuse of the system by users or programs. So modern protection concepts have evolved to increase the reliability of any complex system that make use of shared resources. So protection can improve reliability by detecting latent errors at the interfaces between component subsystems. Early detection of interface errors can often prevent contamination of a healthy subsystem of a malfunctioning subsystem. So the role of protection in a computer system is to provide a mechanism for the enforcement of the policies governing resource use. So as you know, the complete OS is full of programs only, that is .exe files. So one program should not interface when they are interfacing with these one program to another program. There should not be any error. That if error is not there, that increases the reliability of any complex system that makes use of these shared resources. So we'll make sure that one program should not interfere with another program. At the time of interfacing, there should not be any errors occurs, and ultimately we will provide the reliability of the operating system for the user. So that is what programs you can include in this operating system to provide the protection of the complete OS at the same time the complete programs in the system. These policies can be established in a variety of ways. Some are fixed in the design of the system, while others are formulated by management of the system. Policies for resource use may vary by application and they may change over time. For these reasons, protection is no longer the concern solely of the designer of any operating system. The application programmers needs to use protection mechanism as well to guard a resource created and supported by an application subsystem against misuse. The mechanisms are distinct from policies. Mechanisms determine how systems will be done. The policies decide what will be done. So the separation of policies and mechanisms is important for flexibility. Policies are likely to change from place to place of time to time. In a key time tested guiding principle of protection is the principle of least privilege. It dictates the programs, users, and even systems to be given just enough privileges to perform this task. So an operating system following the principle of least privilege implements its features, programs, system calls, and data structures. So that failure or compromise of a component does the minimum damage and allows the minimum damage to be done. Minimum damage. Such an operating system also provides system calls and device services that allow application to be written with fine-grained access controls. So it provides mechanisms to enable privilege when they are needed and to disable them when they are not needed. So what I want to say in this one, goals of protection means our OS should have some programs, some mechanisms, what these mechanisms will do. So the programs which are available in the OS, when they're interfacing one to one, that time they should not be an error to the other programs. The existing the application program should not interfere with the application programs. So there should not be any damage. So that the failure or components of a compromise of a component does the minimum damage and allows the minimum damage to be done. So if at all any problem is there, that should be very minimum. So there should not be any problem to application programs. So that is the main goal of our protection. So The limits of amount of damage that can occur if something goes wrong. If at all something occurs, there should be minimum damage to the system. The minimum damage. So the typically each user is given their own account and has only enough privilege to modify their own files. The root account should not be used for normal day-to-day activities. The system administrator should also have an ordinary account and reserve use of the root account for only those tasks which need to root privileges. So managing users with the principle of least privileges entails creating a separate account for each user with just privileges that the user needs. So the principle of last privilege can help produce a more secure computing environment. Unfortunately, it frequently doesn't. So the protection policies limit the access of each process with respect to their resource handling. A process is bounding to use only those resources which it requires to complete task in the time limit that it requires and also the mode in which it required. This is a protected domain by a process. So if this is domain of protection. The protection policies limit the access of each process with respect to their resource handling. So there must be a program which restricts the access of resources also in that domain. A process is bound to use only those resources which it requires to complete tasks. So process should have the access to other resources which are not permitted. So the process is bound to use only those resources which it requires to complete the task. Only those resources in time to complete the task in time. That process will be permitted to take those particular resources in time. Limit that it requires only and also the mode of in which it required. That is the protected domain of a process. That is so whatever the process requires, which resource requires, so that they are limited. In the sense, they can only access and they can only they will not give any permission to access the other resources. The computer system has processes and objects, so which are treated as abstract data types, and these objects have operations specific to them. A domain element is described an object, set of operations on object. So any process is doing any operation, that is object, and an object is nothing but a work. So a domain element is described as object, set of operations on object. What operations we are going to do in that particular object, that is called domain, a domain element. Each domain consists of set of objects and operations that can be performed on them. A domain can consist of either only one process or a procedure or a user. Then, if a domain corresponds to a procedure, then changing domain would mean changing procedure ID. ID objects may share a common operation or two. Then the domain overlap. So this is domain 1, domain 2, domain 3. So if they are having common operations, the print is a common operations on these domains. This is overlapping. So this is object 1, 2, 3 on this domain. So this is object 1, 2, 3 and 4 on these domains. So what is, we will see association between process and domain. The processes switch from one domain to another when they have the access rights to do so. It can be of two types as follows: fixed or static. So in a fixed association, all the access rights can be given to the process at the very beginning, but they give rise to a lot of access rights for domain switching. So a way of changing the contents of the domain are found dynamically. Changing or dynamic. So in a dynamic association, where a process can switch dynamically, creating a new domain in the process if need to be. So a domain can be realized in a variety of ways. So each user may be a domain. In this case, a set of objects that can be accessed depends on the identity of the user. Domain switching occurs when the user is changed. Generally, when one user logs out and other user logs in. So each process may be a domain. In this case, A set of objects that can be accessed depends on the identity and the process. Domain switching occurs when process sends a message to another process, then it waits for the response. Each procedure may be a domain. In this case, a set of objects that can be accessed corresponds to the local variables defined within the procedure. Domain switching occurs when a procedure call is made. So domain is nothing but a procedure, a domain. So at that time, at what objects it is, on what object is working, that is domain and objects. They're interrelated. The model of production that have been discussed can be viewed as an axis matrix, so in which columns represent different system of resources and rows represent different production domains. Entries within the matrix indicates what axis that domain has been to the resource. We'll see this one. This is a domain 1, 2, 3, 4 and objects, and that particular domain, what objects were what objects are working. So this is F1, F2, F3, these are the objects working. That is in this one, in domain 1, read permission is there for the F1 object, and for F3 object read permission is there. So this is nothing but access matrix. For that diagram we have shown in this one. Each entry in the matrix consists of a set of access rights. Because the column defines object explicitly, we can omit the object name from the access right. The entry access ij defines the set of operations that a process executing in domain dj can invoke an object oj. So here, so there should not be any unauthorized access to other resources. And once we are doing some job on one particular domain, on one particular object, so only authorized work only can be done. So in that particular object, what in the particular domain, what action is permitted, the limited what the resources is permitted. So only we can do that one only. That is nothing but access matrix. So if one domain doing one job and one particular object, it won't disturb other objects. There should not be any interference between the other objects in that particular domain. The access matrix scheme provides us with the mechanism for specifying a variety of policies. The access matrix can implement policy decisions concerning production. The policy decisions involves which rights should be included in the ij entry. The user normally decides the content of the access matrix entries. When a user creates a new object OJ, the column OJ is added to the access matrix with the appropriate initialization entries as is indicated by the creator. So what permissions are there? Read and write permission, execution permissions are there on the domain, on that particular object. So the user may decide to enter some rights in some entries in column J and other rights in the other entries as needed. So the access matrix provides an appropriate mechanism for defining and implementing strict control for both static and dynamic association between process and domains. Process should be able to switch from one domain to another. Switching from domain DI to domain DZ is allowed if and only if the access rights which belongs to access IJ. So only one function is executing. So from when it is executing, on what object it is executing and what rights are permitted for that object, only that only permitted. So we should not interfere with other objects. So thus in figure shows, in this figure which shows a process executing in domain D2 can switch to domain D3 or to domain D4. A process in domain D4 can switch to D1 and one domain to D1 can switch to D2. So we can see this one. This is the domains and these are the switcher to from D1 switcher to D2 like this. So this is a access matrix which demands objects. So this is your access matrix. So access matrix is a predetermined. Whenever any other creates any project, any program, so you should give the permissions. The file, we can say that file permissions. So that unnecessarily we don't execute other objects. So a system may select only one of these three copyrights, or it may provide all three by identifying them as separate rights: copy, transfer, and limited copy. Need a mechanism to allow addition of new rights and removal of some rights. So we can give the file permissions. Same way, we can give the permissions. We can write the permissions. So need mechanism to allow addition of two new rights and removal of some rights. So the owner right controls these operations. If access IJ includes the owner right, then a process executing in domain DA can add and remove. So this is objects and these are the domains. So what permissions are there, and only it will execute those permissions only. It will not touch other permissions. So goals of protection access matrix. If you look at this previous diagram, it is as good as we can add, I can remove by using the certain mechanism to that domain, to that object permissions, right? Owner read permission, execute permissions, write permissions, read permissions, owner write permissions, owner read. Sometimes we can restrict other people should not access our file, our program. So that is, so we'll see the global, what is the implementation of access matrix, a global table. So this, the simplest approach is one big global table with domains and objects and rights entries. Unfortunately, this table is very large, even if sparse, and so cannot kept in memory without invoking virtual memory techniques. So there is also a good way of specifying groups. If everyone has access to some resource, then it still needs a separate entry for each evil domain. So access list of for objects. So each column of the table can be kept as a list of the access rights for that particular object, discarding blank entries. For the efficiency of a separate list of default access rights can also be kept and checked first. So capability list of domains. So a domains capability list is a collection of objects and the actions that can be done on them. A capacity is a name of the address that is used to domain an object. If you want to perform operation M on object OJ, the process runs operation M specifying the capability of object OJ. The simple process position of the capability implies that access is allowed. In most cases, capability are separated from the other data in one of the two ways. Every object has a tag to indicate its type, capability, data. So alternately, a program address space can be divided into two portions. The program may access one portion, including the program's normal instructions and data. And the other portion is a capability list that is only accessed by the operating system. So it means that whatever program you write, that program will have instructions and data, and at the same time, second portion is having the rights, that is permissions, the file permissions. So the OS OS will be protecting this one. If another person want to open that file, if it is not permitted in the file permissions, it won't give permission to that person to open that one. So that is called, that is the other portion is the capability list, that is only accessed by the operating system only. Say a lock key mechanism. It is a compromise between the access list and the capability list. Each object has a list of locks which are specially bit patterns. On the other hand, each domain has a set of keys that are specially bit patterns. So a domain-based process could only access an object if domain has key that specifies one of the locks on the objects. The process is not allowed to modify its keys. So this is take an example to understand the implementation of the access matrix in the operating system. So this is already given permission by the owner of the file. So this is the domains and this is the objects. So this is only restricted. So for this one, this is only read permission. So if anybody want to write, so it won't give permission. That's nothing but. So in this example, there are 4 domains and objects in the above matrix, and also consider 3 files including F1, F2, F3, and on a printer. Files F2 and F1, F3 can be read by a process running in D1. A process running in domain D4 has the same rights as D1, but it may also write on files. So only one process running in domain D2 has access to the printer. The access matrix mechanism is made of various policies and semantic features, especially where we should ensure that the process running in domain D1 DI may only access the objects listed in row 1. So this is called how access matrix is designed, and it is almost, it is designed with the programmer and who has made the project or program. So you will give the permissions that whenever you give permissions, automatically access matrix is designed. So this access matrix will be controlled by the OS. So access control, role-based access control, RBAC assigns privileges to users, programs, or roles as appropriate, where privileges refer to the rights to call certain system calls or use certain parameters those calls. So RBAC supports the principle of least privilege and reduce the susceptibility to abuse opposed to SUD or SJID programs. Privilege can be assigned to processes, limiting them to exactly the access they need to perform their work. Privileges and the programs can also be assigned to roles. So users are assigned roles or can take roles based on a password to the roles. So this is our access control. So the implementation of privileges decreases the security risk associated with the super users and set UID programs. This is process and privileges 1, 2, 3, role 1. So as for the role only, the processes will be given the access to the resources. So revocation of access rights. When with an access list scheme, revocation is easy, immediate, and can be selective, general, partial, total, temporary, or permanent is desired. So with capability list, the process is more complicated because the access rights are distributed throughout the system. So a few schemes that have been developed include reactivation, back pointers, indirection keys. So in this one, so what is reactivation? Periodically capabilities are deleted from each domain. If a process wants to reuse capability, it may find that capability has been deleted. The process may then try to reacquire the capability. If process has been revoked, the process will not be able to reacquire the capability. So a list of pointers is maintained with each object pointing to all capabilities associated with that object. Whenever revocation is required, we can follow these pointers, changing the capabilities if necessary. So this scheme was adopted to the multi systems. It is quite general, but its implementation is also costly. So indirection and indirection keys. So the capability of point indirectly, not directly to this object. Each capability points to a unique entry in the global, which is in turn points to the object. The table entries can be reused for other capabilities without difficulty, since both the capability and the table entry can contain the unique name of the object. So a key is a unique bit pattern that can be associated with the capability. A master key is associated with this each object. It can be defined or replaced with the set keep operation. When a capability is created, the current value of the master key is associated with the capability. When the capability is exercised, its key is compared with the next master key. If the key is matched, the operation is allowed to continue. Otherwise, an exception condition is raised. So we'll see the coming in the session. So capabilities based systems and what is Hydra.
Like, share and subscribe. Hit the bell icon for more updates.